this is the third part of the video where we'll be assembling the modules and battery, and we'll be finishing the assembly of the robot. So let me tell you what parts are there. We have the chassis here. The chassis is all pre-assembled, and we have we have assembled this chassis in the last video. We have the battery set. We need a 12-volt supply for this, so we have 8 AA batteries. This we have 8 AA batteries. This comes with an RMC connector, and the kit doesn't include the battery, so I have put a new set of batteries here. You can use a rechargeable battery also, and then we have this ET spacers. We have nuts, and we have some screws. All these are for mounting your board. So this is the ultrasound obstacle detector board. The sensor here is the obstacle HCSR04 ultrasound obstacle sensor. This sensor will sense the distance between any obstacle which comes in the path of it. So this with the output of this obstacles detector is taken into the Atmega 328 microcontroller. So the Atmega 328 microcontroller senses the calculates the distance between the obstacle and your robot. So the controller is programmed in such a way that whenever there is an obstacle within 20 centimeters, so the robot has to stop, and then it will take a different direction, so it will not collide into the obstacle directly. So it is a simple robot. The output of your Atmega 328 goes into the L2390 motor driver. So the motor driver's output, there are 4 pins which are connected to motor 1 and motor 2 each. There's a power supply pin here where we can connect the battery supply. So let's go ahead and mount this one into the chassis. So we'll use this ET spacers. We have 4 holes here. Let me see where it aligns to, and I'll use those particular spaces only. Just make sure that this part is the front where you are mounting, so your the robot is moving forwards and it will detect an obstacle here. So I have few of the holes aligning. I just put 2 screws here. So I'll have to put a screw from the top. I'll just hand tighten this. You can fix the screws firmly, and make sure that you don't over tighten it and break the bolts. So I have mounted all the 4 spacers. I'm mounting the board onto the chassis. Okay, so it is done, and from the bottom side you can see the ET spacers extensions have come out. You can put these small nuts and mount it. So these boards basically come in 2 types. One is the pre-assembled kit, which is just like this, and one is your non-assembled kit. For your non-assembled kit, you'll have to solder all the components which comes in a different pack. All those soldering instructions, your mounting you have all the schematic diagrams and board diagrams in your manual, which is there in the CD. You'll have to follow that and do the connections exactly like those images which are available there. And also follow the keynotes so that you don't do any mistakes in connecting the parts. A few warnings like on the wires, if in case if there is any wire on the board, you'll have to solder the wire first, and there's instruction on the direction of the IC, the notch, and the direction of the boards and your LED connections. uh, Please follow that and make sure that all your connections are right so that you don't damage your board. These are for the non-assembled kits. So here we have mounted the board, and let me connect the motors. I'll connect one of the motors on each side of the L2390 driver. So right now I'm connecting it in the random direction. I'm not considering the polarity. Finally, when we turn on the robot, we can do the calibration. Okay, so we have done the connection. So we'll use the 8 cell battery. I'll put it from inside and take this RMC pin. It goes in only one direction, so there's no chance of reverse polarity. So if I turn on, immediately the wheels will start rotating. Okay, so we have got the direction of the wheels right, and it is moving forward. The robot moves forward. If I leave it like that, so the robot moves forward like this. Uh, the battery holder is not uh, always mounted. You will have to use a small double tape and just fix it so that it will not fall from your chassis. So the mounting is not okay. So put tape. Uh, in case you if you have I have got the motor directions right here. So in case if you have done the direction in reverse by chance like this, I'll show you an example. Okay, so the reverse direction I've simulated the error, and if I turn it on, so you can see this motor is reversed right now, and this motor is going forward. So you'll have to just interchange this polarity so that initially it will start moving forward. Just reverse this. Okay, so we got both the motors right now. We'll just give an obstacle and check if it is trying to stop or not. So if I get an obstacle, you can see the directions of the motors are being manipulated. Okay, so let me put this on the ground and see how it works. It will change the directions and move around. So you might just think about what applications can be done with this robot. There are infinite number of possibilities with this chassis. You can place a small vacuum cleaner on this and leave it on the floor. It is an automatic vacuum cleaner system, so it hits any of the corners and it will just come back and it keeps picking the dirt on the floor. And similar things, they can you can make any kind of applications and start building it. So this is the end of the ultrasound based robot building tutorials. So keep building uh, the different kinds of robots, and thank you so much.